possible appears to bypass encoding of information. Encoding cannot be eliminated entirely because communication itself is the creation of a shared pattern. What can be bypassed is human symbolic encoding, words, in favor of communication that works by directly sharing state or directly constraining outcomes. One approach is sharing state instead of sending messages. The receiver directly measures the sender's physical or physiological state through a coupling channel. Examples already exist in brain-computer interfaces. Language-like encoding is bypassed, but a mapping still exists. The receiver must interpret measurements, even if that interpretation is learned automatically. In future systems, ultra-low latency coupling between devices or between brains and devices could allow intent to become an actionable control signal without being consciously translated into words. Systems can share information by synchronizing clock or randomness, which reduces uncertainty without transmitting a large message payload. Entanglement does not transmit controllable messages by itself. It enables alignment and coordination with extremely low marginal energy cost. A closely related approach is continuous or analog coupling, where meaning is carried by dynamics. In these systems, information resides in phase locking, resonance, or coupled oscillations, as seen in phase-locked lasers, coupled mechanical resonators, or synchronized neural stimulation and recording loops. Discrete encoding schemes are bypassed. The most speculative but conceptually plausible path is direct neural-to-neural interfaces. In principle, two nervous systems could be linked through implants that read and write neural patterns. Early versions would only transmit low-dimensional intent states, such as yes, no, left, right, urgency, or attention. This would not be telepathy, but shared, trained mappings of simple internal states like intent, confidence, or emotion. There are also hard limits on what cannot be bypassed. Communication always requires a physical carry, whether light, electrical signals, or chemical gradients. Representation cannot be avoided entirely. If a receiver can distinguish outcomes, that distinction itself constitutes an encoding, and entanglement alone cannot be used to send messages faster than light. In practice, a bypass encoding future looks like a layered system rather than a single breakthrough. Nuclear and solar energy provide abundant baseline and distributed power. Photonic networks move data with minimal loss. Edge devices use excitonic or spin-based logic to reduce heat, and interfaces focus on state sharing rather than commands. Devices continuously infer intent and context instead of being explicitly instructed. Encoding is not eliminated. It becomes implicit, learned, and automatic. Communication feels like it bypasses encoding because humans no longer translate thoughts into messages. The system meets them at the level of state.